Okay, so the last video we were checking for proportion. Now I'm going to give you 3 examples of how we use that setup of proportions to solve actual problems. So notice what this says. Darryl reduced the size of a frame. So he started off with a larger frame, reduced the size of a frame to a width of 1 inch. What is the new height if it was originally 25 inches wide and 125 inches tall? So this, we want to keep proportionality. So remember what we said, if we want to keep this width with this height proportional to this width to this height. So let's go ahead and do that. Let's say we want to keep the height 125 inches and the width of 25 inches proportional. Well, the height over on the left side is x and the width is 1. Well, remember what we did for proportionality? We cross multiplied. So we're going to multiply 1 times 125 is equal to x times, here, let me put the 1 and let me put times 25 because we're going to cross multiply to keep things proportional. Well, 1 times 125 is 125. X times 25 is just 25x. And then we're going to do an inverse operation. Well, what's the inverse of multiplying? What's the opposite of multiplying? Yeah, dividing. You guys already knew that. And if you don't know the answer to that in your head, you've got a calculator right there on your desk. Go ahead and do 125 divide by 25, and you're going to have 5, but then you need to tack on the inches symbol. So x is equal, this height right here would equal 5 inches. Now we're going to do another example. So we've got these 2 shapes, and we need to find when it says similar, by the way, when you have that information, it means they're proportional. So give you an idea. If we said that this side is proportional to this side, you might put that tick mark. If this side is proportional to this side, you would just do a double tick mark. And then the bottom side, you might do a triple tick mark. That's just telling you which sides are proportional. And so we might do the same thing. 4 is proportional to 10. Oh, sorry about that. I just hit my keyboard. Let me do this. Get rid of that. Okay. And I think I have this down here. So I did the shorter side. Oh, so notice what I did. This might be a little bit confusing. You can set, I'm going to cover this up really quickly. You can set it up 2 ways. You can compare the same triangle, so 4 is to 10, so that's the shorter side, the longer side, as x is to 50, and then cross multiply. Or you can compare the short side to the short side of the bigger triangle. So you could compare 4 over x, so this is the smaller, this is the larger triangle. Well, 4 is the shorter side, or the shorter side of the shorter triangle, then we're going to do as 10 is compared to 50. And again, you're going to cross multiply. So let's check this way. I did 4 is to 10 as x is to 50, and I'm going to cross multiply. Well, we'll have 50 times 4 is equal to 10 times x. 50 times 4 is 200. Is equal to 10x. 10 is being multiplied x, so the inverse of multiplying is dividing. Then the 10's cancel. 200 divided by 10 is 20, and then we'd say 20 units. Well, let's see if this works out. Well, now we have 50 times 4. But this time the 10 is already up there, we're going to cross multiply and we're going to bring to x. Look at this right here. As long as you're comparing the same triangle, so short side to the longer side is the short side to the longer side, or you're comparing the similar sides to each other, 4 is to x as 10. You just have to make sure that when you do it this way, the sides that you're comparing are similar to each other. Okay, so now we're going to do one other. This has to do with a map. Find the distance between Smithville, so here's the city of Smithville, and here's the city of Riverside. And in real life, they're this far apart, but on a map, it might look like this. So find the distance between Smithville and Riverside if they are, so this point right here, this line right there is only 8 centimeters apart on a map. But the scale is 1 centimeter on a map is proportional to 6 kilometers. Well, 8 centimeters. So notice the centimeters. So this is the map and this is real. So I would put 8 centimeters, and we need to know the exact, and this would be in kilometers. So you could cross multiply. So notice I'm comparing the map to the real. So 1 is to 6 as 8 is to x, and then I'm going to have 1x is equal to 8 times 6, which is 48. Well, 1x is x. So that's going to be 48 kilometers, which means if they're 8 centimeters apart on a map, in actuality, they're 48 kilometers apart. The other way to do this, and maybe I did it this way here. No, I did it that way. Let me show you the other way you could do it. You could compare the centimeters to centimeters. So 1 centimeter, this is the map, and this is the map. Well, 1 centimeter compares to 6 kilometers, and we don't know how many kilometers, right? So when you cross multiply, you still get 1x is equal to 48 kilometers. Just like that. And I think that is the 3 example. That is. All right, that's it. Proportional reasoning.